This video is going to cover a few more examples on negative exponents and using that rule for negative exponents. So for these next three examples, the instructions tell us to simplify each exponential expression using the rules for exponents, and all of these involve, again, those negative exponents, so we're going to have to see that rule being used for these examples for 24, 26, and 28, which again are questions out of our textbook. So 24, for this question, we have x over 2, and that's being raised to this negative 5 power. So to start this problem, we're going to go ahead and write this as x to the negative 5 over 2 to the negative 5. So this is following that quotient to power rule. And now that we have this here, again, we have negative exponents in both locations. So the idea with this is that we're just going to rewrite this as 2 to the positive 5 power over x to the positive 5 power. And so now that we have this, and there's no negative exponents, the last step would just be to evaluate what is 2 to the 5th power. So 2 to the 5th power means to do 2 times 2 times 2 times 2 times 2. That ends up being 32 over x to the 5th power. And that would be the final answer for that question. For 26, there are actually multiple ways that you could go through and solve this problem. I'm going to go through the method that is probably a little bit more straightforward, but again, there's a lot of options. So the first thing that students usually will see with this question is that we have a product to power. So going back to lesson 5.1. So to start this, we could rewrite this as basically, again, distributing that negative to both factors within this set of parentheses as 2 to the negative 3 times, and this would be x to the 4th to the negative 3 power. And then we could actually separate this out just so that we can have a little bit clearer view of what we're working with in this set of parentheses. So negative 3 times y to the negative 7 power. So now that we have this, we can go ahead and go through and say, well, 2 to the negative 3 power, this now is going to be 1 over 2 to the 3rd power times this right here. We're going to multiply again using the power rule. So 4 times negative 3 is negative 12, so you'd have x to the negative 12 and times negative 3, and then we can go ahead and rewrite this as 1 over y to the 7th. So now on our next step, so moving along, this 2 to the 3rd power we can actually evaluate. That's going to be over 8 because 2 times 2 times 2 is 8. So we're going to have 1 over 8 times 1 over x to the 12, because again we're going to flip this part so that it's underneath, times negative 3, which we can think of this as being over 1. That might help us to consolidate this all into one product here. And then we got 1 over y to the 7th. So yeah, we're not going to leave our answer like this. We're going to actually consolidate it. And so this is going to end up equaling negative 3 over, and this will be 8x to the 12th y to the 7th. So basically just putting all of our denominators together and our numerators, and that will be our final answer. So that's example 26. And then for this last example, this again is going to involve several of our different rules for exponents, including our negative exponent rule. So to start this problem, you could use, kind of similar to number 24 that we did up above here, you could go through and distribute this 3 to every single part of this quotient, but that would actually be quite a bit. So my advice is to look inside of the parentheses and see if we can do any simplifying in here. And we actually can, because we have bases that are the same, and so we can use the quotient rule to simplify what's going on the inside here. So this is going to turn into, this is going to be 8, and then negative 4 minus 3 is negative 7, so this will be m to the negative 7. And then this is going to be 5 minus negative 1, so that's going to turn into 6. And this is still inside the parentheses because we have not removed the exponent on the outside. So now at this point, now that we have a little bit less going on the inside, we can go ahead and use now that product to power rule. So this is going to turn into 8 to the 3rd times m to the negative 7th to the 3rd times n to the 6th to the 3rd. 8 to the 3rd power, so 8 times 8 times 8 is going to be 512, times, this is going to be m to the negative 21st, times n to the 18th. And the only thing now we have left to take care of is the fact that this is a negative. So as I was saying, we're going to try to get rid of this negative exponent here, or should I say we're going to get rid of this negative exponent by applying that negative exponent rule. And we're going to rewrite this as 512 n to the 18th, because that's going to stay on the top of our fraction bar. And then m to the 21st is now in the denominator, in the denominator. And this would be the final answer. So that is some more examples for rules for negative exponents.